Hello students, now we'll discuss the question number 64. So question number 64 is talking about they're given some molecules. We need to find out their hybridization as well as their shape. Now there's a small trick is there for the calculation of hybridization. So now we'll discuss what exactly meaning, how to find out easily. So trick to find out so here, so hybridization is equal to number of sigma bonds plus free bond pair. So this is a very easy trick that we can able to find out. For this, we need to draw the structure for this one. So if you are able to draw the structure, so then we can able to find out the any molecule hybridization very easily. Now let's solve this one. So one by one, let me explain you very clearly. Suppose first component what they're given is xenon trioxide. So here Xe xenon trioxide. Xenon belongs to the first of all, it belongs to 18th group. So it's having the 8 valence electrons are there. 8 electrons are there in its valence shell. So now let us keep the xenon here center. Now, so here oxygen will be the divalent. That means what happened? It can able to form the double bond with the xenon. So it is forming the two electrons. That means three oxygen will take two electrons, three into two, six electrons committed. So how many left out? So two electrons will be left out as a lone pair. Now can count here number of sigma bonds. Here one pi bond, one sigma bond, one pi bond, one sigma bond, one pi bond, one sigma bond. That means what happened? Three sigma bonds are there. Three sigma bonds plus one lone pair is there. That means total is four is coming. If total four is coming, that is a sp3 hybridization. If sp3 hybridization is there, now you can see here lone pair is there. If lone pair is there, the structure looks like pyramidal. You can see the structure, it is clear, look like a pyramidal. Like you can draw like this, no? Like this. It look like a pyramidal. So the A must come sp3 hybridization as well as pyramidal shape. So this two will come, A2 will come. Along with that, now the next statement is xenon difluoride, second one. So A is completed. Now B you can take it as the given Xe difluoride. Fluorine is a monovalent. Fluorine is a monovalent. Now let us take xenon having 8 electrons. We'll make it like this. Fluorine below one fluorine. Now here two lone pairs. So total 8 electrons are there. 8 electrons, two has been completed. Now how many left out? Again 6 electrons are left out. So what I'm keeping here? One lone pair here, one lone pair on this side. Again two lone pair on this side. So here we have two sigma bonds plus three lone pair. That is coming total five. That is sp3 hybridization. sp3d hybridization. Now, what is the shape of this one? The shape is you should take this one linear. Only six bonds alone we have to take. The linear will be the shape. Linear is the shape. Shape will be the linear. Now, so what option will come for us? The option will be so sp3d hybridization as well as linear shape. So sp3d as well as linear. So first statement is coming in. So V2 is coming now. Now question. Now the same statement three. Statement three. What will state that XeO4. So again one oxygen will be having the it is a divalent whereas a fluorine is monovalent. So what I'll give here oxygen I'll give it at the top and fluorine I will keep it as a equatorial position like this. Now, so there are four electrons for fluorine and two for this one. Now, another lone pair is there. So we can keep here as a this one. So it will be look like. So what? How many sigma bonds are there? One, two, three, four, five sigma bonds are there. Five sigma bonds plus one lone pair. So total is coming six. Six means sp3d2 hybridization. sp3d2 hybridization with the this hybridization. If it is coming sp3d due to hybridization, now so based on this, we'll see the shape how it look like. You can see the shape of this one. Can draw like this. One square is there, and above the square, one pyramidal is there. That means what happened? Square pyramidal is the structure. So option sp3d2 as well as square pyramidal. So C4 will be clearly appearing. Now remaining will be, we'll see the last statement that will be, so what we have last statement is that is D statement. So D statements what we have XeF6, XeF6. So right, draw the structure of this one. So XeF6 will make here one fluorine here, one fluorine here. First I am placing the equatorial position. Now here one fluorine, here one fluorine. Okay. Now again two more are there, right? Here one fluorine, here one fluorine. Now we'll keep here one lone pair. So here six electrons, six sigma bond form, one lone pair is extra. So it will be the lone pair to bond pair repulsion is there. That makes them like distorted octahedral. It looks the structure will come distorted octahedral. Octahedral. Why distorted octahedral structure is coming? Because of the repulsion between the due to repulsion between the repulsion between lone pair to bond pair repulsion that makes them to distorted octahedral. Now, how many sigma bonds are there? Six sigma bonds plus one lone pair is there. Total is coming seven. That means sp3d3 is coming. So you will be having the option number. So it will be this is the so D will be the three statement. That means A2 B1 A2, B1, C4, D3. So you'll get the option number is 1 is the answer. Thank you guys. Hello students. Question number 65. Question number 65, what is telling that? So the given the reaction formation of methane. Formation of methane, it is the carbon solid H2 gas combining from the CH4 methane. Now you can see here the del H value as given is negative. Negative value represents. So let us discuss here. What is the key concept involved here? Key concept will be involved here is so heat of reactions. Heat of reactions. In the given case, suppose first what happened here? First statement. If del H value is negative, then it is the exothermic reaction. Exothermic reaction. In exothermic reaction, so energy of products is lesser than energy of reactant. Energy of reactant. Now, in case of case 2, what happened? Case 2, if del H value is positive, that means endothermic reaction. Endothermic reaction. Endothermic reaction. So that means what happened in this case? Energy of product is more than energy of reactant in this case. So for this, how the graph will come? So for endothermic case, you will get the energy versus reaction coordinates. So in case of endothermic, you may get the graph like this, like this. So here, if we see there, uh, let me see how we can represent the energies of reactant as well as product. So here, this value is represent energy of reactant, whereas this value represent energy of product. Now, whereas this one, this gap represent is a del H value. Now, when you see the for a case of exothermic case, what happened? Exothermic case, what happened in this case? So, in case of exo, how the graphs look like? Here, energy versus reaction coordinates. RC means reaction coordinate. So here, like this to come. Now, this is the graph for exothermic. Now, we'll indicate their energy file clearly. So, this much will be the energy of reactant, and this much will be the energy of products. Now, here you can see here, this value represent for us is the del H value that the given here is minus 74.8. So the option what we are getting here is option A is the right answer for this question. And see here, this much will be our del H value. This is not the del H value. It is the activation energy we can represent, right? So the option, correct option for us is this one.